everyone, my name is Rocco Ancora and welcome to Eizo monitor calibration for photography workflows using Color Navigator 7. The monitor is the most important piece of the jigsaw puzzle in your color management workflow, as it is your only true window into your image file. And monitor calibration is a non-negotiable component of that workflow. The three most important components in my creative workflow are accuracy, efficiency, and productivity. Accuracy, because I want to make sure that the colors that I'm seeing on my screen are true. Quality, it really comes down to the end product that we're trying to produce for our clients. And efficiency is knowing that once I set my parameters in my monitor, they're not going to change. Time is money, efficiency is everything. Before we begin calibrating our monitor, let's talk about our viewing conditions. The color temperature of the light around us affects our color perception. Our eyes tend to always discount the color of the illuminant. What that means is that if I hold a sheet of white paper underneath tungsten light, to my eyes it will appear white. And if we do the same by holding it outside in daylight, it will still appear white. Ideally, what we want to do is set D50 lighting in our environment. To achieve D50 lighting, the first thing we need to do is to remove any strong colored lighting from our environment. What that means is absolutely no fluorescent and no normal tungsten. If you have fluorescent light in your ceiling, you can try swapping them for some GDI color accurate tubes. Or if you have tungsten lights, you can try swapping those for cool white versions, balanced to 5000 Kelvin. But if you have downlights, you can then use the Solux 12 volt globes. The idea here is to make sure that the lights are not affecting our perception of how we see our screens by outputting light that is the wrong color. All monitors, for graphics technology and for photography, calibrate to an international standard. That standard is ISO 3664. Let's begin with the brightness levels of your monitor. It is recommended that the brightness be set anywhere between 80 to 100 candela per meter squared. This is for editing photographs on a screen. This setting, however, is going to depend on the brightness of your surroundings. For example, if you're working in a bright environment, as your eyes adjust to the ambient light, the monitor may appear too dark, as it may have been set to a low luminance value, and vice versa. As explained earlier, it is important to have the ideal viewing conditions for your monitor. 120 candela per meter square is a good starting point, and we can take things from there. The problem of having an overly bright screen is more evident when we print our work. If the screen is set too bright, then the resulting prints will be too dark. In other words, our screen is showing us the right colors, but just an overly bright version of those colors. For my editing environment, my screen is set to 100 candela per meter squared, as this gives me a good correlation between brightness of my screen and my prints. This, of course, may vary in your own editing environment. I will discuss matching print to screen in a later section of this video. ISO 3664 also stipulates the white point that we need to set our monitor to, and that is D65 or 6500 Kelvin. The gamma we leave at 2.2 or native. So now that we have our basic parameters to get started with monitor calibration, let's launch Color Navigator 7 and calibrate the monitor. We're inside our Color Navigator 7 software, and on the left-hand side, we have our 10 different color modes. Now 1 to 8 are existing modes with pre-configured target values, and we can access those based upon the different workflows that we might be engaging in, whether we're, say, working purely for web as web designers and want to employ perhaps an sRGB workflow. All of the parameters are already preset in there, and all we need to do is say calibrate. Or perhaps we could be doing video and we are using an REC 709. But color modes 9 and 10 are essentially empty, and we can use them to enter our own target settings depending on what state we want to calibrate our monitor to. Now, in each of these, of course, we can have multiple targets. The 10 different color modes can be accessed by pressing the mode button on the front of the screen. By pressing the button, we can quickly change our monitor to a different calibrated state. So let's select our Cal1 color mode, and inside of that we are going to create a new target. And the target we are going to create will be ISO 3664 for our editing work. And we're going to enter, of course, our values manually. Just click onto the arrow here. And the first thing that we need to do, I guess, is give the target a name. So we're going to call this ISO 3664. And another thing I want to do also with the profile is put in the brightness of the monitor that I'm calibrating to, because with ISO 3664 the recommended brightness is anywhere between 64 to 160, but this really comes down to the environment that you're in. We discussed earlier about the monitor being the brightest thing in your field of view. So just as a rule of thumb here, 120 candela, if you were in an overly bright room or a standard sort of office environment with lots of lighting, because we still need the monitor to be the brightest thing in our field of view, that would be a really good brightness to use, 120 candela. However, if we bring that brightness down, which is recommended for editing, anywhere between say 32 to 64 lux. 64 lux is what I'm using in my environment. I have that right down to say 100 candela. So here in the name, I'm going to put 100 candela so that I know that ISO 3664 at 100 candela is what I've calibrated to. Now, another thing here is that if I click onto this checkbox and set color mode name, what I can do, I'll just move these out to the side. What I can do is I can call this, say, editing. And what this will do, once I finish, of course, setting the target parameters, it will change that mode name from Cal1 to editing. And of course, inside of that, I can have multiple targets if I want to. So by clicking that, I'm changing the name of the mode as well. Okay, so we've set our brightness. Let's move down to black level, which we'll leave at minimum. White point, color temperature, we'll leave at 6500. Our gamma, we leave that at 2.2. Our priority is going to be standard, as this is a screen-based target. The gamut we'll leave as native, and I'll explain a little bit later in this video the difference between native and standard value. And the ICC profile policy we'll leave as is at every calibration. Once we're happy with all this, we'll hit OK. So on the left hand side here we have the parameters that we've entered for our target, and if we're happy with all of that, we'll hit Calibrate. We'll choose our measurement device. This monitor that I'm using has a built-in sensor. If your monitor doesn't have to have a built-in sensor and you need to connect an external one, whichever one you connect to your computer will appear here in this menu. We'll hit Next, and we'll click on to Proceed to calibrate the monitor. Once calibration is complete, we can see our results here on the right hand side based upon our brightness settings and of course our white point and the contrast that we have achieved for our monitor. We'll click on Finish. We can see here on the left hand side that editing now has become one of our color modes, which I can easily access through the mode button at the front of the monitor, and of course also in the Color Navigator software. One of the great features of Color Navigator 7 in conjunction of course with the Eizo monitors is the ability for the software to control when the monitor is calibrated automatically, of course, without you actually being present. So if we go here in the monitor settings and we go into management policy, here we can actually specify how often we want our monitor calibrated and when we want to calibrate it. So I do periodic calibration and I have enable self-calibration box ticked, and I can either do it by usage time, in other words after X amount of hours here specified, the monitor will go and calibrate itself based on the parameters that of the current profile that we're in, or what I like to do is actually pick a specific date or a specific and a specific time. So I have mine calibrating weekly, and it calibrates every Monday at 7 a.m. So I have this set to 7 a.m. What that means is every Monday morning at 7 a.m. before I walk into the studio, the monitor will do its thing. It will calibrate, and it won't interrupt with any production time whatsoever. And this is an awesome time-saving feature of Color Navigator 7 in conjunction with the Eizo monitor. I want to explain a little bit more about the gamut of the monitor itself and the gamut option inside Color Navigator 7. Inside here we have two options, whether we tick the native box or the standard value. In other words, we either calibrate with all of the colors that the monitor can display, or we limit those colors to a specific color space, whether it's Adobe or sRGB and so on, depending on your workflow. Now, 99.9% of the time, I am ticking native for the very simple reason I'm working in a big color space, ProPhoto RGB, and I'm outputting to a fine art paper with a custom profile, and I'm able to print some really extensive colors. And I'm going to show you the difference of ticking these two boxes and how those two different options plot out onto the spectrum locus as far as their respective profiles. So here we're in a program called ColorThink. I'm going to switch on my profile, which has been created using the native option. And this is what it looks like, and this is what it looks like compared against the Adobe RGB, which is a solid red line. So you can see that the monitor is actually able to display a lot more colors outside of Adobe RGB in certain areas. As a comparison now, if we turn on ProPhoto RGB, which is the far larger color space, you can see that the monitor, even though it can't show us ProPhoto RGB colors, it's certainly showing us a lot more colors than Adobe RGB. And this is why I choose native when I'm actually calibrating my monitor. Now, having said that, of course, there is no right or wrong, depending, like I said, on your workflow. And if your workflow evolves around Adobe RGB, well, then so be it. We'll keep on doing your calibration to Adobe RGB, because you might be, outputting to a commercial lab, and this is what they require of you, and these are the colors that you want to work with. But at the end of the day, whether you choose native or standard value will really depend on your personal workflow. If you're printing your work and want an accurate rendition between screen and print, calibrating to ISO 3664 just isn't enough. The brightness might be accurate between our screen and our print, but our white point and contrast will differ from paper to screen. This depends on, of course, what paper we're printing on and our viewing conditions. The reason for this is there are different versions of white, because our brains keep on adjusting the color that we see based on the lighting conditions. If we hold a blank piece of our favorite printing paper under tungsten light, it will appear white. If we do the same under window light, it will also appear white, and so on. If we were to compare a blank sheet of paper against the pure white document opened in Photoshop on a monitor that's calibrated to D65, the monitor will appear too blue by comparison. Our environment, for example, might be lit by tungsten light, which is around 3800 Kelvin, and our eyes will have adjusted to that. Even with D50 lighting, our D65 monitor will still appear too blue. Another variable to this equation is the base color of our printing paper as well. Some papers, especially the fine art papers, tend to have a warmer base, and that warmth will vary from paper to paper. Standardizing lighting conditions for the accurate appraisal of prints is imperative. So where do we start? For the practical appraisal of prints, ISO 3664-2009 P2 viewing conditions recommends D50 lighting and a brightness of 500 lux, plus or minus 125 lux for tone reproduction evaluation. To make my evaluation between screen and print, I use a D50 light booth with variable brightness control. This allows me to set the specific luminance. Alternatively, we can use other means of achieving D50 lighting in our environment. We could install 12-volt Solux globes above our workstation, as shown in this image on the screen. We could also install GTI Graphic Light 100 color viewing lamps, which are the fluorescent type. Or quite simply, we could also use a Felix desktop color viewing lamp, which is also dimmable. Whichever method you use, the idea here is to standardize our viewing conditions. As mentioned, contrast is also an issue. Our monitor, calibrated for editing purposes, yields a contrast ratio of around 1000 to 1, maybe sometimes even greater than that. The contrast of printed media is usually around 200 to 1, and sometimes even less, depending on the paper that we're printing on. So how do we change this? Quite simply, in Color Navigator 7, we can adjust the black point in relation to our monitor brightness. If my brightness level is 100 candela, then my black point will be 0.5. 100 divided by 0.5 gives me 200, 200 to 1 ratio. If my monitor brightness is set to 80, then my black point will be 0.4. 80 divided by 0.4 gives us 200, 200 to 1. So now let's launch Color Navigator 7 and create a target for our printing appraisal. Here we are in Color Navigator 7 and we are going to create a new target for our printing workflow. We're going to select one of our color modes, one of our empty ones, which is Cal 2. And in this, we are going to create a new target setting and we're going to enter our parameters manually. Before we give the target a name, let's talk about some of the settings, beginning with our brightness. The brightness you'll set will depend on what brightness is going to give us a good match between our monitor and the print density. This, of course, is going to be based on our viewing conditions. Now, assuming that 100 candela already gives us a good correlation as far as density is concerned between monitor and print, we'll stick with 100. We then have to come down and set our black level because we want to bring the contrast down of the monitor to around 200 to 1. And because we have chosen here 100 as our brightness, our black point or our black level should be set to 0.5. 100 divided by 0.5 is going to give us that 200 to 1 contrast ratio. The next thing we need to adjust is our white point. 6500 Kelvin, as we mentioned earlier, is still going to appear too blue in relation to our D50 viewing conditions. So I'm going to bring that value down to 5800 Kelvin. I find that 5800 works really, really well, and it gives me a pretty good match between all of the different papers that I choose to print on. Our gamma is set to 2.2. The priority here I'll set to grey balance, as this is going to be a soft proofing target. Gamut, we're going to leave that as native. In the ICC profile policy, we're going to leave that at every calibration. Let's go back to the top now and give the target a name based on the parameters. I always like to include the parameters in the name as it makes it easy for me to then work out what I've done with the actual target itself. For example, the brightness that we've set for this target is 100 candela, so we'll put that in. The white point that we've set is 5800 Kelvin, so we'll put that in as well. And of course our black point, because this automatically is going to tell me that we achieved a lower contrast just by looking at the name. So 0.5 candela per meter square. Then what I'm going to do for this one is I'm going to set the color mode name. And the color mode name that I'll set is print. So I'll be able then to access this through the mode button on the front of the monitor as well. So once I'm happy with all of that, I am going to click on OK. And this is the target name, and this is the parameters that we've set in. We'll click on Finish. So all we've done now is set the parameters for our target, but now we need to calibrate. And once we're ready to do that, we'll hit the Calibrate button. we'll select our measurement device. This particular monitor that I'm using has a built-in sensor, but if your model doesn't have this, then whatever sensor you have connected to your computer will be displayed here. We hit next, and we click on to proceed, and the calibration process will begin. Once calibration is complete, our results of what we have achieved with our calibration are here on the right hand side. Our brightness, our black level, and of course, most importantly, our contrast. And also our screen, you'll note, has become warmer. We'll click on finish, and over here you can see that now our color mode number 10 is for printing, and I can quickly change that state of the monitor to an editing state by clicking on editing. And of course, I can do this also on the front of the monitor by clicking onto the mode button, quickly changing from editing back to print. A far more accurate way to achieve print to screen match is to use the manual adjustment feature of Color Navigator 7. This allows us to adjust the monitor to match our print viewing conditions and obtain a better correlation between screen and print. The first thing we do is create a white document inside of Photoshop. And we want to make sure that we fill the entire screen with this document, getting rid of any tools and distractions that are on the screen as well. So it's nice and clean, and we'll launch Color Navigator 7. Inside Color Navigator, we'll bring up our print target that we created earlier with that 200:1 contrast ratio and 5800 Kelvin white point. We're then going to take a sheet of our favorite printing paper, and we're going to put that in our viewing conditions in our light booth here, our 5000 Kelvin light booth, and we're going to compare that to our screen. And we can see that the white of the screen appears a lot bluer than the white of the paper. So what we need to do now is go back into Color Navigator 7, and we can manually adjust to get a better visual correlation between paper and screen. Click on Advanced Functions, Manual Adjustment to bring up our Manual Adjustment menu, and inside of here we can adjust our white point and brightness. And we'll adjust the brightness and white point until we get a better visual correlation between our screen and our paper. Once we have achieved a good match between screen and paper, we hit Next. We choose our measurement device. In this case, once again, it's our built-in sensor. We'll hit Next again. We'll click on to proceed, and the monitor now will calibrate based upon the new inputs for our white point and our brightness. Once calibration is complete, this is the result from the new manual adjustment. So our brightness now has come down to 89.8 candela per meter square. Our black level is down to 0.041. And of course our contrast ratio remained at 218:1. And our white point is 5279 Kelvin. I can now rename this target name. I'm going to leave the 90 candela and 0.5 candela as my black point. But right next to that, I'm going to put in the name of the paper that I've actually just matched, which is the Aquarel rag. I'm going to click on Finish. And now in my print mode, the Aquarel rag will appear as one of my targets that I can quickly switch to when I'm printing on that particular paper. And if we don't have a viewing booth to do this, as long as we have D50 lighting set up in our environment at the correct brightness, we can hold a sheet of paper up against the white of our monitor and perform exactly the same procedure to achieve a better match between screen and print. As mentioned earlier, the monitor is your only true window into your image file. Eizo and Color Navigator 7 software allows you to easily achieve and maintain consistent, accurate results from capture right through to final print. I'm Rocco Ancora, and thanks for watching.